After the differentiation of composite function, I will take differentiation of one more type function, that is differentiation of implicit function, IMPLICIT, implicit function. Before that, let us try to learn some basics which are essential for differentiation of implicit function. Differentiate the following with respect to x. Okay, differentiate the following. Find dy by dx. Instead of differentiate the following with respect to x, take this one. Find dy by dx. Okay. First one, y is equals to sin x. Second one, y is equals to cos 3x. Third one, y is equals to root of a square minus x square. Fourth one, y is equals to 1 upon 3x square plus 5x plus 6 whole raised to 5. Fifth one, y equals to sin square x. Okay. Now first one is, look here. Look at the question, find dy by dx. If, okay, y's are given, I have work out dy by dx. First one is y is equals to sin x. Okay. Now to find dy by dx, differentiate the given equation. Differentiating with respect to x, differentiate the given equation with respect to x, because okay, y is the function of x, then we have to differentiate with respect to x. Try to understand one basic point. If y is equals to sin theta, means y is the function of theta, I can differentiate with respect to theta. Differentiate with respect to theta means we have to take d by d theta on both sides. Suppose y is equals to a t square plus bt plus c. Try to understand all these basics. Then y is the function of t. Then I have to differentiate this function with respect to t. Means dy by d by dt should be taken on both sides. Okay. So if y is the function of theta, then differentiation with respect to theta means you have to take d by d theta. If y is the function of variable t, then you have to differentiate with respect to t, means you have to take d by dt on both sides. Okay. So here is y is the function of x, therefore differentiating with respect to x. Okay. Now here the left hand side, differentiating with respect to x, I told now you have to take d by dx. Differentiating with respect to x means you have to take d by dx on both sides. Therefore d by dx of here y. So in the bracket y are simply y, one is the same. Okay. dy by dx is equals to d by dx of sin x. In bracket sin x you put, that will be more better than simply without bracket. But here only y is there, no need of putting the bracket. Therefore dy by dx, what is the dy by dx of sin x? It is cos x. Time differentiation is cos x. Therefore dy by dx is cos x. Second one, same differentiation, but here we are using the one additional point here, y equals to the given function. Y equals to some function is there, then function of x is there, we have to work out dy by dx. Okay. Same differentiation, no difference. Okay. Y equals, so far we have given like that. Differentiate the following with respect to x. Functions are given simply sin x, cos 3x, root of a square minus x square, 1 upon 3x square plus 5 plus 6 whole raised to 5, like that it was given. And we have straight away started with d by dx of cos 3x, d by dx of root of a square minus x square, d by dx of 1 upon 3x square plus 5x plus 6 whole raised to 5, like that. D by dx of sin square x, one and the same. There is nothing wrong in taking the given function as y. Then differentiate with respect to x, you take one and the same. Both procedures are one and the same. Okay. So here specifically dy by dx is asked. Therefore, I have called all the function as y equals to sin x, y equals to 3x, etc. I have taken all the function as y equals to f of x. Okay. Second one, y equals to cos 3x. Differentiating with respect to x. Now dy by dx. Differentiating with respect to x means you have to take d by dx on both sides is equals to d by dx of cos 3x. Now d by dx of, what is the cos 3x? Even though it seems to be in the form of cos f of x, I have given the shortcut. Cos ax differentiation is minus a sin ax. Therefore it is minus 3 sin 3x. A is 3 here. Okay. Sin cos ax differentiation, d by dx of cos ax is a is 3, minus a sin x. Of course, it is in the form of cos f of x. F of x is 3x. Cos f of x differentiation is minus sin f of x into d by dx of this f of x 3x. 3x differentiation is 3 into 1, 3. That 3 is taken in the beginning shortcut. Okay. Instead of using cos f of x, it is better to take the formula cos ax. If simply f of x is ax. Okay. Third one, look at the dy by dx for the second problem. Third problem is y is equals to root of a square minus x square. Now it is in which form? Root f of x. Okay, composite function root f of x. But before that one, write the statement differentiating with respect to x means you have to take d by dx on both sides. Okay. Therefore, dy by dx is equals to what happens? Therefore, dy by dx is equals to here d by dx differentiating with respect to x means take d by dx. The d by dx of root of a square minus x square. I will repeat, with the differentiation of root f of x, d by dx of root f of x is equals to 1 upon root f of x into d by dx of f of x. Okay, into d by dx of f of x. That's it. What is f of x here? Root of a square minus x square. What is f of x here? Root of a square minus x. Sorry, a square minus x square is f of x. Therefore, the answer is 1 upon 2 root f of x. F of x means a square minus x square into d by dx of inside means f of x a square minus x square. Okay, d by dx of at the outset it is root. Therefore, root f of x differentiation 1 upon 2 root f of x into d by dx of the quantity inside the square root, that is a square minus x square. That's equals to 1 upon 2 root a square minus x square is left hand side dy by dx into with the a square differentiation constant 0 minus now a square minus x square differentiation of t. A square differentiation d by dx of a square is 0 because a is constant, then a square is also constant. Constant differentiation is 0 minus d by dx of x square. X square differentiation is 2x. Whenever plus or minus is there, you have to differentiate each and every terms. Okay. D by dx of f of x plus or minus g of x plus or minus h of x is d by dx of f of x plus d by dx of h of x plus or minus d by dx of g of x, etc. Okay, that's equals to 1 upon 2 root a square minus x square into minus 2x. No? 0 minus 2x is minus 2x. 0 minus 2x is minus 2x. Then after differentiating a square minus x square, I got a square differentiation at 0. Then d by dx of x square is 2x. D by dx of a square, a is constant, differentiation is 0. D by dx of x square, x raised to n formula, 2 into x raised to 2 minus 1 is 2 into x raised to 2 minus 1 is 1. 2x raised to 1 is 2x. Therefore, 2 cancels. Finally, the answer is dy by dx is equals to dy by dx is equals to minus x upon root of a square minus x square minus x upon, okay, 1 into minus x upon root of a square minus x square. It is better to write the minus in the middle class. Minus of x in the numerator root of a square minus x square. Okay. Now, the fourth one, y is equals to 1 upon, to take the fourth one, y is equals to 1 upon 3x square plus 5x plus 6 all raised to 5. It is in which form? It is a composite function. It is in the form of 1 upon f of x raised to n. Okay. Now, differentiating with respect to x, dy by dx is equals to d by dx of 1 upon 3x square plus 5x plus 6 all raised to 5. I would like to highlight one point here. Look here everything is x. Therefore, the equation is in terms of x. The function is the function of the variable x. I am differentiating x with respect to x. So far we did like that only. The function of x are differentiated with respect to x only. Okay, then only the differentiation formulas are applicable. Okay, means d by dx of x is there here, sin x means variables should be matching of variables should be there, x and x. Then only it is cos x. Okay, suppose d by dx of sin theta is there. Okay, then here x, here theta. That's equals to cos theta is only cos theta is the wrong answer. Okay, let us see. If here is the function of one variable and you are differentiating with respect to another variable, what to do? That comes in the later on stage. Okay, but mind one point here. I am differentiating a function of x with respect to x, then only I can take the respective formula. Sin differentiation is cos x provided the differentiation with respect to x which d by dx. Okay, d by dx of x raised to n is n into x raised to n minus 1. Because I am differentiating x raised to n, variable is x here, function here the variable x is respect to x only. Then only the formulas, respective differential coefficient formulas are applicable, n into x raised to n minus 1. Okay, x function of x can be differentiated with respect to x only, not with respect to other variable. Then only differentiation of a function of x can be differentiated with respect to x only. Differentiation of function of theta can be differentiated with respect to theta only. Instead of d by dx of sin theta, d by d theta of sin theta. Look at variable in matching theta, theta. Then it is cos theta is correct. Okay, look at the difference. d by dx of sin theta is cos theta is wrong because variable in mismatching. Here is x, here is theta. But d by d theta of sin theta is cos theta is correct because variable in matching theta and theta. Therefore, while differentiating, the variable matching should be there. What function you are differentiating? It is the function of certain variable. That function can be differentiated with respect to that variable. Then only I can write down the respective differentiation formula. What so far we have taken. What are the differentiation formula so far taken are valid one if you are differentiating the function of a certain variable with respect to the same variable only. Okay. If with respect to some other variables is there, I can carry out the differentiation, but additional technique is required. I will explain that one later. Now, it is the 1 upon f of x raised to n differentiation. Therefore, what is the 1 upon f of x raised to n differentiation? Minus n upon, minus phi upon. It is in the form of 1 upon f of x raised to n. Okay? 1 upon f of x raised to n is minus n upon, minus phi upon f of x raised to n plus 1. 5 plus 1 is 6 into d by dx of f of x. What is the f of x here? 3x squared plus 5x plus 6 is the f of x. 1 upon f of x raised to n differentiation minus n upon f of x raised to n plus 1 means f of x is 3x squared plus 5x plus 6 raised to 5 plus 1, 6 into d by dx of this inside f of x 3x squared plus 5x plus 6. For clarity, you revise the video again and again. Then dy by dx is equals to, I will erase it, dy by dx is equals to minus 5 upon 3x squared plus 5x plus 6 whole raised to 6 into now the differentiation of, now I will work out the differentiation of 3x squared plus 5x plus 6. Okay, 3 outside, x squared differentiation, 2x into 2x. Okay, it is all sum of 3 terms here. Sum of 3 terms are there. If we have to differentiate each and every terms. Now d by dx of 3x square is taken. 3 outside, constant is taken outside the d by dx. X square differentiation 2x plus 5 d by dx of 5x. D by dx of 5x. D by dx of 5x. 5 outside. D by dx of x, that's 1 plus d by dx of 6, 0. Finally, it is minus 5 into 3 into 2x is 6x. 5 into 1 is 5 upon dy by dx upon 3x squared plus 5x plus 6 to 6. That is the dy by dx. Okay, this answer is called differential coefficient of the function y. Okay. Last one, sixth one, y equals to sin square x. differentiating with respect to x. Y is the function of x, therefore I can differentiate with respect to x. If y equals to sine square t, then I have to differentiate that one with respect to t. Means you have to take d by dt. If y equals to sine square theta, means variable is theta, I have to differentiate with respect to theta, means you have to take d by d theta on both sides. Okay? Differentiating with respect to the variable x, dy by dx is equals to d by dx of sin x the whole square. Sin square x means sin x the whole square. All trigonometric functions raised to n is there, it should be taken as whole raised to n. Now it is in the form of f of x raised to n. What is the differentiation of f of x raised to n? N into f of x raised to n minus 1 into d by dx of f of x. Okay? That's equals to 2 times of sin x raised to 2 minus 1 into d by dx of sin x. I will repeat. It is in the form of f of x raised to n. It is a basic differentiation, basic composite function differentiation. Okay? F of x raised to n differentiation, n into f of x raised to n minus 1 into d by dx of f of x. F of x is sin x here. F of x raised to n, f of x is sin x. N into f of x raised to n minus 1 into d by dx of this f of x. F of x is sin x. F of x raised to n. It belongs to which category? F of x raised to n category. Okay? Now, it is 2 times of sin x. D by dx of sin x is cos x. Raised to 2 minus 1 is 1. Sin x raised to 1 is sin x. That's equals to sin 2 times of sin x cos x is sin 2x. Very useful trigonometry formula, multiple angle formula. It's called multiple angle formula because angle x is not there. 2x is there. 2 into x, multiple angle. Therefore, sin 2x is formula 2 times of sin x cos x. Okay, sin 2 theta is 2 times of sin theta cos theta. One formula. Another formula for sin 2 theta is it is 2 tan theta upon 1 plus tan square theta. Okay, when our time comes, I will explain all those things. In the beginning of quantities, this year vacation class, all were explained in the classroom. Now coming to the differentiation of implicit function. So far, look here in the problem 1 to 6. Look at the equations in problem number 1 to 6. So look at the equation y is equals to sin square x. The second one is y is equals to sin x. Like that, y is equals to the functions like y is equals to sin x, y is equals to 1 upon 3x square plus 5x plus 6 whole raised to 5. Y equals to a square minus root of a square minus x square, etc. So far what is taken in the above problems, etc. are called explicit functions, are called explicit functions. Explicit functions are called explicit functions. While here y and x are expressed separately. Y on one side, x on another side. No, look at all the equations. Y on one side, x on another side. Therefore, it is explicitly x and y are explicit. Means x and y are explicit separately. Then how to get dy by dx in case of explicit function is taken just now. Okay. Now, so what is the implicit function? Now coming to the implicit function concept. What is the implicit function? If x and y are in the mixed form, x and y are in the mixed form, then they are called implicit function. In general, y is equals to, y is equals to f of x. Means here y, here only equation of x are called, is called explicit function. Okay. Explicit function. In case of explicit function, how to get dy by dx? So just now we have discussed it in 4 5 simple problems we have taken. Okay. Later on, difficult differentiation of explicit function, some difficult functions we consider it later. Okay. Now y is equals to f of x comma y equals to c. Look at f of x comma y means here the function of not only the variable x. Here f of x means here is the function with variable x only, means an expression, an equation only in x. Here f of x comma y equals to c, where c is a constant. So here the function means equation is involving both the variable x and y. F of x y is equals to c. Means in the expression x y are in the mixed form. In the lay sense, x y in the equation x y are in the mixed form, and such functions are called explicit functions. Such functions are called implicit functions. If y and x are expressed separately, y equals to f of x, explicit function. X and y are in the mixed form, f of x y equals to c, where c is a constant, is called implicit function. Implicit function. In the simple way, if x and in an equation x y are together, not expressed separately, are called implicit function. For example, x square y plus xy square plus 3xy is equals to 10. So look at x and y there, x and y there, x and y there. So second one, sin x plus cos y is equals to 0. Here x is there, y is there, like that. Third one, tan x into y is equals to sin x plus sec y. Okay, x and y are in mixed form in the expression. X is not expressed separately in terms of y, or y is not expressed separately in terms of x. X and y are in mixed form, etc. are called, etc. means f of x y equals to c. X and y are in the mixed form, not expressed separately, etc. are called explicit functions. Again I'm repeating the same mistakes, etc. are called implicit functions, etc. are called implicit function. Might have this, but it is line might have not visible on your screen, but I repeat, tan x into y is equal to sin x plus y, where x and y are mixed together in the expression. So x and y are in the LHS as well as RHS, or x and y are together in LHS. Such expressions are called as what? Implicit functions. X and y are not expressed separately, they are together. Such functions are called implicit functions. In case of implicit functions, how to get dy by dx? That's the question here. How to get dy by dx for an implicit function? To get dy by dx for such implicit functions, f of x y is equals to c. In general, it is called implicit function. So to get dy by dx for implicit function, we have to learn some basics. Okay. So look here. d by dx of x raised to n is equals to n into x raised to n minus 1. Is it right? But d by dx of y raised to n, look here, x is here, here y, variable is y raised to n is not equals to n into y raised to n minus 1. I told now, here is the function of y. You can't differentiate with respect to x. Function of y can be differentiated with respect to x only. Function of y can be differentiated with respect to y only. Function of theta can be differentiated with respect to theta only. Function of t can be differentiated with respect to t only. Here it is t, equation in t, here you should get d by dt. Here it is y, you should get here d by dy. Here it is theta, you should get d by d theta here. Okay? So one variable, function of a certain variable cannot be differentiated with respect to other variable. Okay? What to do then? It is not equal to n into y raised to n minus 1. Y is not equal to, here it is written, but here it is, why it is wrong? Look at the difference. Here x with respect to x is there, matching is there. Okay? Matching of variable is there. Then that with respect to differential coefficient formula can be taken. Here variable matching is not there. Therefore, so I can't write it as n into y raised to n minus 1. Then how to differentiate the function of a certain variable with respect to another variable? Chain rule is to be taken. Which rule? Chain rule. Okay? Try to understand this, what it is, differentiation properly. When this differentiation is understood, the differentiation of implicit function is simple. Okay? But again I am talking about d by dx of y raised to n. I told you y can be differentiated with respect to y only. That's why simply I am writing it as d by dy of y raised to n. d by dy of y raised to n. Simply I am writing it as d by dy of y raised to n. Because y raised to n can be differentiated with respect to y only. Therefore, I have introduced dy here. Okay, but this dy is taken additional. No? Therefore, into dy, and what about this dx is taken here. Okay, is it anything different? Any wrong in the equation? This expression and this expression are one and the same. Dy is additionally taken. Why additionally taken? Because y can differentiate with respect to y only. That's why I introduced dy here. Then this dy is additionally taken in the denominator. Now to cancel it, in the numerator it is multiplied, dy cancelling, and this dx is taken here. Ultimately it is same as d by dx of y raised to n. This expression has not changed literally, but we are in the stage where we can differentiate y with respect to y. What is the y raised to n differentiation? N into y raised to n minus 1 into dy by dx. dy by dx can be taken as y dash, or even dy by dx can be represented by y dash also, or it equals to y1, or it equals to what? F dash of x, one and the same. Okay, these symbols can be used interchangeably. In place of dy by dx, I can put it as y dash or y1, or if y equals to f of x, I can call dy by dx as f dash of x. I can call dy by dx is equals to f dash of x. Okay, if y equals to f of x, then if y equals to f of x, then dy by dx can be taken as f dash of x. Okay, n into y raised to n into dy by dx. For example, here, this is the chain rule. Okay, this is the chain rule. Y is differentiated with respect to y, and into dy by dx taken. This introducing dy by dx, differentiating of y with respect to y, and this dy is taken additionally. In order to cancel it, into dy by dx is taken, and this technique is called as a chain rule. Okay, for example, d by dx of y square, that's equals to d by dy of y square into dy is taken additionally. Why additionally taken? Because I can't differentiate y with respect to x. I can differentiate y with respect to y only. Therefore, into dy by dx. Why? Where is this dy? This dy is taken additionally in the denominator. Not to cancel it, into dy. This dx is taken here. That's equals to y square differentiation with respect to y. A usual formula, 2 into y raised to 2 minus 1. Y raised to n differentiation, just like x raised to n. Variable may be anything. X raised to n, y raised to n, z raised to n, theta raised to n. If it is with respect to the same variable, then n into this variable raised to n minus 1. Okay, into dy by dx. So that is the differentiation of y square with respect to x. Okay, y square with respect to x. But mind that one, but the dy of y square is there. Here variable is matching y with respect to y. Then it is 2y raised to 2 minus 1. That's all. It is 2y. No hurdles, no problem in differentiating this particular equation, because y with respect to y is there. Variables are matching. Simply it is n into y raised to n minus 1 into dy by dx won't appears. When dy by dx appears, into dy by dx, if y with respect to x you are doing, then into dy by dx additional term should be taken. For example, one more example. Let us take one more example. d by dx of, second example, sin y, that's equals to y with respect to x is not possible. Differentiation of function of y with respect to x is not possible. Therefore, dy of sin y into dy by dx. Therefore, sin y differentiation of y with respect to y is there. Okay, now I can write down the differential coefficient of sin y, that's equals to cos y into dy by dx. Okay, this into dy by dx will be additional. Third one, d by d theta of cos theta, sorry, d by dx of cos theta. Okay, here the variable is theta, here is x. Then is equals to d by d theta of cos theta, chain rule. Okay, d by d theta of cos theta, theta with respect to theta is taken, into this d theta is additionally taken, therefore d theta by dx into d theta by dx. What is this dx? Here this dx, no? Look here, this dx is shifted. Cos theta differentiation with respect to theta, variables are matching, therefore I can write down the differentiation formula, minus sin theta into d theta by dx. Let us take some more in the next session of this differentiation of a certain variable with respect to another variable, how to differentiate it. Just take down some more example. After understanding all those things, you can differentiate composite functions. Sorry, explicit functions or implicit functions.